Fossil fuels are horrible for the planet. Dirty burning, heat trapping, climate changing sources of energy. We need to stop using these to power our modern world. The solution to this problem is renewable sources of energy. Renewables come in multiple forms, from hydroelectric dams to wind turbines that spin. Currently, the third largest contributor to renewables is solar energy. Solar energy accounts for 1.5% of the US's total energy generation, and is currently the largest growing sector of it. And that's great, but what do we do about all of this here? There's going to be a graphic behind me where it's like showing all of the energy that is produced by fossil fuels. We all know we need to cut down on our fossil fuel addiction, but where do we find the space? We can only build so many dams, so many turbines, and dedicate so many fields to solar panels. So what if there's a way to increase our solar capabilities right now with existing space? Hello everyone, my name is Ben McKenzie, and I'm just a 12th grade student trying to educate people on climate change. There's a lot of negativity surrounding climate change, and for good reason. It's a major problem, but that doesn't mean there's a lot of progress being made to fight it. I personally believe that it is much more helpful to tell people about the good in the world, as being so negative all the time just leads to people feeling unmotivated and sad. So it's my goal to spread positivity and hope for the future. In this video, I wanted to talk about a cool piece of technology that I found, and it's called solar windows.
Now, you may be thinking, aren't solar panels already made out of glass? What makes these any different? Well, basically, solar glass is what would happen is if you just took that normal solar panel and just made it clear. With the clear panel, you are able to use these as a window, which means you can produce electricity on buildings all over the place. I mean, think about how much window there is in the world, and then increase that amount, because there's a lot more than you think. In the US alone, there's an estimated 5 to 7 billion square meters of glass, with 2.4 billion being installed about every year. Now imagine what would happen if we replaced all of that glass with electricity generating solar windows. That would be a lot of power. According to Michigan State University, doing so would provide 40% of the US's energy demands just from these solar windows. But how much is 40% really? For 2023, the US says that they'll need to produce 4,014 terawatt hours of energy, which is this massive number here in watts. That means these solar windows have the potential to reduce this massive number down to 2,408 terawatt hours. Now, of course, this is the most positive of positive projections, but imagine if we change out even a little bit of that glass with the solar glass. That's still going to be a huge offset. Now, on a smaller scale, how do these windows affect you? Like, if you had them installed in your house, what would they do for you? In ideal conditions, there's been reports of these windows generating 200 watt hours of energy a day, which basically translates to charging your current gen iPhone about 13 times in one day. That's a good amount of energy. And imagine if you didn't need to plug into the wall in order to charge that, because another potential application for this tech is to put it on your phone. Now, imagine a world where all of this solar glass is everywhere, not just on your buildings, but it's on your phone, on your laptop, on your car. That would passively charge throughout the day, increasing battery life and reducing the amount of time that you have to plug in your car during the night. Okay. You've heard a lot about the positives of this, but how does this actually work? Now, normal solar panels work by absorbing all the light and then concentrating it and powering solar cells, which then make the electricity. But if all the light is going through it, how exactly does it, power? Now, the cool thing is that it is absorbing light, just not the light we see. It's absorbing ultraviolet and infrared light, the wavelengths just above and below the visible light in this electromagnetic spectrum. By focusing on these two wavelengths of light, you get to, have your window, and you also get to have your energy come in, which that's a pretty smart idea. Now, how does the glass actually work, right? How does this generate power? Well, it works much the same as normal panels, using luminescent solar concentrators, or LSCs. But the thing that makes this different is that they made it British and added a T on top. TLSCs are made out of chemical salts, which concentrate in ultraviolet and infrared light, the light spectrums just above and below visible light. So these are concentrating light, just not the light that we can see, and turning those into power. When the TLCs are exposed to these wavelengths, they begin to glow in near infrared frequencies, and no, you can't see it. These frequencies are then directed to the edge of the frame, where they begin to power the solar cells, which make electricity much in the same way that a solar panel would. This electricity can then be fed directly into the building or into the surrounding power grid. While these solar panels probably won't power an entire skyscraper, they'll definitely help offset the electricity that they do use. Also, as a side note, remember how I said that TLSCs absorb infrared light? Well, you probably know, but infrared light is the one that carries a lot of the heat. So you are actually reducing the amount of heat that gets into the building, which further reduces the amount of electricity being used in the building because people won't need to turn on their ACs as much, right? And air conditioning is one of the leading uses of electricity in the world. The US alone uses 409 terawatt hours for air conditioning alone every year. Technology is never just bam, poof, into existence. I wish it was though, that would be cool. But that begs the question, who's actually making all this stuff? There's a few companies in the world who are for working on this stuff, so I just wanted to talk about them really quick. So the first one is Ubiquitous Energy, one of the first ones to actually get involved in this. Ubiquitous Energy was established back in 2011 by some of the original researchers on solar windows. They set up the company in 2011 and got their first patent in 2012. Since then, they've continued research and development, increasing the efficiency of these panels and also balancing it with the transparency of these panels. In 2016, they developed their first large-scale prototype, which balanced both the efficiency and transparency needed to rival actual windows. It measured only 1 foot by 1 foot, so not exactly massive, but that's still a very big improvement. And they haven't stopped R&D as well. In 2022, they unveiled their first really large-scale model. It measured 1.5 by 3 meters, so that's really big. And it worked with the same efficiency and transparency, which is really, really impressive because that shows that this technology scales up without losing either of those. Due to this, Ubiquitous Energy was able to partner with Andersen Corporation, one of the leading glass and door manufacturers in the world. This partnership will help Ubiquitous bring this technology to a wider market and also make it easier for architects to incorporate this tech into their designs.
Solar glass is a very exciting technology for the future. With it still being relatively new, there's a lot of potential for it to grow. The tech is very promising and does have actual units out there in the world right now working on making energy. But, there's still some problems to iron out. The first and biggest hurdle is the size of the panes that are produced. Most of the glass panes that are installed in buildings right now are, kind of small, only around 14 by 20 inches. Sure, this may look kind of cool, and I could personally get behind this being in my house or in my office, but it may be a limiter for some people. People like their big windows. Just ask modern architects. Look at any skyscraper right now, and it's just big columns of glass downtown all over the place. And I could get into about how skyscrapers are like bad design for buildings, but that's a topic for another day. In the meantime, if we don't want to overhaul our modern architectural design, but we still want this technology in our buildings, then we're going to have to increase the size of these. Luckily, Ubiquitous Energy, remember them, are planning on building their own production sites, which will allow them to produce these ceiling to floor sheets of glass. Now, unfortunately, these sheets of glass will mostly be sold to commercial clients, so the dream of having this technology in your home in the next 3 to 5 years probably isn't going to happen, but we can only hope for the future. That's awesome. Another thing we have to bring down for the future of this technology is the price. As much as we want good things to happen for free, money still has to flow before we can do all of it. See, I'm criticizing capitalism in my video. As of now, solar glass is costing 30 to 40 times more than passive glass, which is definitely a limiter for a lot of people. Sure, the glass will offset that payment over time, but it still takes a while for it to generate enough electricity to pay for itself. As all technology goes, over time the price will get cheaper because the demand for it will go up, and which will increase the production of it. It's called economics. Yeah. It's called economics. Speaking of economics, there's also something called economies of scale. By printing bigger sheets of glass, you're also able to cut down those big sheets of glass into the small pieces of glass that people actually want. So you may make something absolutely massive, but people only want like that big, right? So you'll cut it down to that size, and a lot more glass gets produced that way, and people will buy it for cheaper. Same idea with TV production. You don't make a bunch of 42-inch screens. You print one massive 100-foot screen and cut that up into the 42s. It's called economies of scale. Teaching you something here.
Bonkers, man.
Thank you. Finally, the next thing we need to improve is the efficiency of conversion. Currently, these panels are working about 5% efficiency, compared to opaque solar panels, which work at 20%. Now, obviously, the clear solar panels just can't be more efficient than the opaque solar panels, because the opaque ones are literally getting more light. But that doesn't mean we can't close the gap. Right now, Ubiquitous Energy is R&Ding a new panel which works at an efficiency of 10%, which doubles the performance of their current gen panels, and is also only half of an opaque panel, which is a major improvement. This is a huge step forward for the technology, and we can only hope to squeeze out that tiny bit more performance in the future.
So, dear viewer, what did we learn today? Well, we learned about the cool new technology of solar glass windows. We talked about how they'll affect our environment in a positive way, how they're produced, and even how they actually work. I don't know about you, but I really want this technology to take off and go as many places as possible. I mean, think about it. A technology like this, which provides clean, renewable energy, saves you money in the long run, and on top of it all, doesn't require any new space. I know it's going to be a great day when this technology becomes available for the masses to buy. Now, I am in no way saying that this is a panacea for all of our climate change needs. There's no miracle cure for this complicated situation we've got ourselves into. There is a lot we need to really address and change in order to dig ourselves out of this hole that we put ourselves in. But these solar glass windows can definitely be a part of that solution. And I hope that this technology can grow and expand in order to put us on that path to a bright, sustainable future. I'm not sure how to write an outro, so I just wanted to take a moment to say thank you for watching this incredibly mid-video. And if you did enjoy it for some reason, please consider subscribing so you can find out when my next video about nuclear power and the myths surrounding it drops. See ya!